What is inside a black hole? A place the universe refuses to explain. There are mysteries in the universe we haven't solved yet. And then there are mysteries the universe seems to actively hide. Black holes belong to the second kind. They are places where space collapses, where time loses meaning, and where the laws of physics, the very rules that describe reality, stop working. We have detected them. We have measured them. We have even photographed their shadows. And yet, beyond that shadow, there is a hard boundary, a point where information can never return. Tonight, we are not chasing science fiction. We are following physics, step by step, right up to the moment where physics itself breaks. The question is simple. What is inside a black hole? Section 1. How gravity breaks reality. Gravity is the weakest force in the universe, and yet, somehow, it wins. A black hole forms when gravity overwhelms everything else: pressure, heat, atomic structure, even space-time itself. When a massive star runs out of fuel, there is nothing left to hold it up. The star collapses inward, violently, endlessly, without limit. This collapse does not create a hole in space. It creates a region where space itself is curved so extremely that every possible path leads inward. A black hole does not pull you in. It removes the option of escape. Section 2. The event horizon, the ultimate one-way boundary. The boundary of a black hole is called the event horizon. It is not a wall. It is not a surface, and you would not feel it when you crossed it. There would be no explosion, no flash of light, no sudden pain. But once you cross it, the universe outside is gone forever. From that moment on, no signal you send, no light, no radio wave, no message of any kind can ever reach the outside world. Cause and effect are cut in half. You are no longer part of the observable universe. You have crossed a boundary where meaning itself begins to disappear. Section 3. What happens to time near a black hole? Time near a black hole behaves in ways that defy intuition. From far away, an outside observer would see you slow down as you approach the event horizon. Your movement would appear to freeze. Your image would fade, and you would never quite fall in. But from your perspective, time continues normally. Your heartbeat feels the same. Your thoughts flow the same. If you looked back toward Earth while falling, you might see the universe outside speeding up, stars aging, galaxies shifting, history unfolding rapidly before your eyes. Near a black hole, time does not stop. It splits. Section 4. Spaghettification, death by geometry. As you fall deeper, gravity becomes uneven. Your feet are pulled more strongly than your head, not because gravity is suddenly stronger, but because space-time is steeper below you than above. This stretches your body into a long, thin strand. Scientists call this spaghettification. It is not violent in the traditional sense. It is not crushing. It is geometry tearing structure apart. In small black holes, this happens quickly, before you cross the horizon. In supermassive black holes, you could cross the event horizon alive, intact, unaware. Death does not happen at the edge. It happens when space-time becomes too distorted to support matter at all. Section 5. Inside the event horizon. No way out. Once inside the event horizon, direction loses meaning. There is no up or away. Every possible future leads deeper inside. Just as you cannot stop moving forward in time, inside a black hole, you cannot stop moving toward the center. The singularity is not somewhere you might reach. It is where all futures end. Section 6. The singularity, where physics fails. At the center of every black hole lies the singularity. According to our equations, it is a point of infinite density, with zero volume and infinite curvature. But scientists do not believe infinities actually exist in nature. In physics, infinity is a warning sign. It means the theory has been pushed beyond its limits. At the singularity, Einstein's theory of relativity collapses. Quantum mechanics cannot describe gravity. Space and time lose all definition. The singularity is not an answer. It is a sign that something deeper exists, something we have not yet discovered. Section 7. What could replace the singularity? Some physicists believe the singularity does not exist at all. Instead, it may be replaced by a quantum structure, a core where space-time becomes granular, not smooth. Space itself may be made of tiny, indivisible units. At the heart of a black hole, space-time may not collapse. It may change phase, like water turning into ice or matter turning into energy. If true, then black holes are not places where physics ends, but places where new physics begins. Section 8. The holographic idea. One of the strangest ideas in modern physics is the holographic principle. It suggests that everything inside a black hole may be encoded on its surface, not inside, on the boundary. This means volume could be an illusion, depth could be a projection, and the universe itself may operate like a hologram, with reality stored on cosmic boundaries. Black holes may be showing us how reality is truly built. Section 9. Hawking radiation and the information paradox. In the 1970s, Stephen Hawking made a shocking discovery. Black holes are not completely black. They slowly leak energy. Over unimaginable timescales, they evaporate. But this creates a terrifying problem. If a black hole disappears, what happens to everything that fell inside? Physics says information cannot be destroyed. Black holes seem to destroy it. This contradiction is called the black hole information paradox. Solving it may reveal the true nature of time, causality, and reality itself. Section 10. The honest answer. So, what is inside a black hole? Not fire, not hell, not a gateway, at least not yet. The honest answer is simple. We do not know. Black holes mark the boundary of human knowledge. They are where curiosity meets silence. Closing. Why this mystery matters. Black holes are not just cosmic objects. They are questions. They force us to confront our limits, our assumptions, and our place in the universe. Inside a black hole may lie the answer to everything. And until we find it, the universe keeps its deepest secret.